So we're talking about when you're substituting in an expression into a function, okay? When you're substituting an expression into a function, you actually have to follow through with simplifying, okay? The goal is to simplify. So, for example, here, we have g of x plus 2. That means where x is going to become x plus 2, okay? So I want you to go through the whole process of simplifying. So we have 3 parentheses, x plus 2 minus 1 squared plus 1. That's going to give me 3 parentheses, x plus 1 squared plus 1. All right, so it's going to tell you to fully simplify in the little blue thing, like simplify. This is not simplified form, okay? Simplified form means that you have eliminated parentheses and combine all like terms. Does that make sense? So this will look like 3 times x plus 1 times x plus 1 plus 1. In the middle, I'm going to use a quote-unquote FOIL. So that's going to give me 3 parentheses, x squared plus 2x plus 1. How did I do that so quickly? Because all I did was, what's 1 plus 1? What's 1 times 1? 1. We reverse factor, right? We multiply. Now I'm going to distribute and combine. So when I distribute, I have 3x squared plus 6x plus 1 plus 1. So in total, g of x plus 2. Yes.
Don't you distribute the 3 1?
What are you talking about, Andrew?
See, I fixed it this time.
What are you talking about? You just saw what you wanted to see.
Okay, yeah.
Yeah. But thank you for if there was something that needed to be. If there, had been something there. So that is what they're expecting you to do. Okay. So not only did we substitute the expression in, we then went through and fully simplified with that expression. Okay. All skills that you are capable of doing. You can FOIL, you can distribute, you combine like terms. This unit goes really fast. Okay. Questions, comments, concerns about plugging? I mean, unless as much as you can do mentally. Other than that, nope. All right, next part is compositions of functions. What is a composition of a function? This is where you are plugging functions into functions, which is what this leads us to, right? So when we're plugging a function into a function, we're coming from plugging an expression into a function. Very similar concept. But fog and goth, F is composed, is what this is saying. F is composed of G. That means I took the whole G of X and I plugged it into F. G composed of F means that I take the whole F and I plug it into G. Which we've already practiced. It just now has a formal name of composing. So when you do this, you're creating a whole new function by marrying them together. So for example, we're going to start off with just evaluating. Evaluating means that I'm plugging in values. Got it? Evaluate means there's a value going in. Okay. So if I have F composed of G at 2, what this is telling me is that I'm going to plug in 2 into G, and then the answer of this, I'm going to plug into F. Does that make sense? Okay, so the first thing I'm going to do is I'm going to do G composed of 2. So that's going to give me 1 over 2 plus 8, which is 1 over 10. I take the result from that and I plug it into F. So now I'm doing F composed of 1/10. which is gonna be 1/110 to the third. When you have a power outside of a fraction, it applies to the numerator and to the denominator. So this is just gonna be 1/1000. And that is my final output. Okay, we're gonna practice again. It also can be written as this way. Again, you start from, you work your way. So this time I'm plugging 2 into F, and then the result of that, I'm gonna plug into G. So we're gonna find F of 2 first. That gives us 2 to the third. What is 2 to the third? 8. Now I'm gonna take that solution, that output, and put it into G of 8. So we get 1/8 plus 8 equals 1/16 is our final output. How do you feel about evaluating with compositions? Putting a function in a function? Good? So it's the last part of 5.1. See, I did. All right, now, this time we are creating new functions. So in the previous one, we were evaluating because we had a value, right? Now it says compose functions defined by composition, okay? So we want to put the function into itself, to the whole thing, and simplify. All right, and then it's asking, do they create the same equation or not? What are you looking for?
Whiteboard.
Okay. So we're gonna take G of X and we're gonna plug it into F. So it's gonna be F composed of 1/x plus 8. So that's gonna give me 1/x plus 8 to the third, which just equals 1/x plus 8 to the third. So that's its composed function. That's it.
Why is it 3 on the bottom?
Because when you have a power, it applies to the numerator and to the denominator. And 1 to the third is just what? 1. All right, so now we're gonna do it the other way. So this time it says you're gonna do F of X, and you're plugging F of X into G. So now we're gonna have G composed of X to the third, which equals, wherever there's an X, it now becomes X to the third, 1/x to the third plus 8. And it's asking, are these the same thing? And the answer is not equivalent. I was trying to decide if I was going to be lazy and just leave it not spelled all the way, or if I should complete the spelling. Okay, now what happens is if they are equivalent, that means that they are inverses of each other. That's what that means. But in this case, they were not, so. All right, and it says now state your domains of your new function. So when we look here, the domain of this function is there anything that would make this equal to 0? No. So the domain here is all real numbers, right? Looking at this one. The domain here, is there anything that would make this equal to 0 in the denominator? -2. -2 to the third is -8, and -8 plus 8 is what? 0. So for this one, X cannot equal -2. Let's do the math. Glad you asked. X to the third plus 8 equal to 0. I subtract 8. Negative x to the third equals -8. Take the cube root. And the cube root of -8 is -2.
What is this, with that?
Math. I'm not being funny. It's just you click math and it should be under there. Okay, so if I plug in -2, it's gonna make my denominator 0, which means that that is a restriction on my domain, right? My domain can be any number except -2.
Would that be a whole or that?
Asymptote. It would be an asymptote. Good question. All right. How do we feel about creating new functions from composition and identifying their domain? Huh? Okay, well, I would like you to practice.
Just because we think good, doesn't mean it's wrong.
Yeah. So here's your shot,
Try.
huh?
Nothing.
What is your problem?
If you want to ask.
I hear you talking, so I assume if I'm teaching, you're talking to me.
Girl, it's work up there. Why would I even see what I'm trying to do?
So the first one you're doing is you're plugging g of x into f, and then you're gonna practice plugging f of x into g. Yeah. All right, here we go. So on the first one, when you plug g of x into f, that's f composed of x to the 4th minus 4x squared plus 1. That wasn't too bad, was it? No, because I'm just substituting it in here. So we get x to the 4th minus 4x squared plus 1 minus 1. Combine like terms, and what happens here? So you got x to the 4th minus 4x squared. That was the first one. The second one got a little tricky, right? So now you're taking f of x, so you're taking this entire thing and plugging it in for x. So g composed of x minus 1 equals x minus 1 to the 4th minus 4 times x minus 1 squared plus 1. Yeah? So if you know what x minus 1 is, so we're going to do x minus 1 in my, I'm like, that's going to give me x squared minus 2x plus 1. Agree? So now I know that there's two of these. What happened?
I did x plus 1 and then I just finished and,
Just change your f of x then in your notes. Make it x plus 1.
okay, I'll do that.
Just change it in your notes. All right, so we have x squared minus 2x plus 1. And it's going to be two of them because x minus 1 to the 4th is the same thing as x minus 1 squared times x minus 1 squared. Agree? So we have x squared minus 2x plus 1 minus 4 times x squared minus 2x plus 1 plus 1. Here you have the choice to distribute or to use the box method. So if you need to see it better organized, be able to combine, that's where your box comes into handy. If you're fine with doing multiple distribution, whatever is your preference, that's what you do. Does that make sense? So x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x to the 3rd. X squared times 1 is x squared. Now I'm going to do negative 2x times x squared is going to give me negative 2x to the 3rd. Negative 2x times 1 gives me, I skipped 1. Negative 2x times negative 2x is 4x squared. And then negative 2x times 1 is negative 2x. Now I have 1 times x squared gives me x squared. 1 times negative 2 gives me, and then 1 times 1 gives me 1. So all together, that comes out to be x to the 4th minus 4x to the 3rd plus 6x squared minus 4x plus 1.
Anyway.
Okay? So then you have negative 4, and that's distribution. So we have negative 4x squared plus 8x minus 4 plus 1. Got real tiny in the end. So when it's all said and done, we have x to the 4th minus 4x to the 3rd. And I have 6x squared and negative 4x squared. And that makes 2x squared. I have negative 4x and positive 8x. That makes positive 4x. And then, oh, I have 1 and 1. And that makes 2. So all together, that is what my blue. Are these equivalent?
No.
No, clearly they're not. Clearly they are not equivalent.
So you don't do it for this, then you can do it.
Oh, did I jump ship somewhere? Probably. Guys, I had a pen. I was writing.
Something you know. But
Yes. You saw, I didn't even pay attention to -4. Thank you. That makes this a. I need to erase part of that line. Never saw nothing. Okay. So you can see the difference of how it could be extremely long or it can be extremely short to compose two functions.
Can you not put this one in test?
Luck of the draw. All right. So I think we're good with practicing it. Now we're gonna talk about reading it from a graph. So how does composition from a graph work? What? Yeah, it's a 16-week course. All right. So when you have a graph, you identify the parts of the graph. So for this problem, the red is my g of x, the blue is my f of x. And it's just like a table. You work your way in. So -2, I'm going to go to g. So I go to -2 and I go to g and I get what? 4. So that means I'm now going to go to f of 4. I go to 4, I go to f and I get. So my answer is 2. That is compositions by a graph. All right, so let's do it again. First, I'm going to go to 1, and then I'm going to go to f. I go to 1, I go to f, and I get 1. So now I'm going to go to g. I'm going to go to 1 and go to g. I go to 1 and go to g, and I also get 1. Yeah? All right, let's do this one. I'm going to go to 0 and go to 0, and I get. So I get 0, and then I go to 0 again, and I get 0. How do you feel about compositions with a graph? Doable? Okay, it works the same with the table. You just bounce around. Okay, so with that in mind, we have a table here. And it says is how to convert gallons to quarts, and quarts to cups. So if I have 4, that's going to give me what? 16. And then I'm going to go exactly. So does that make sense? So if I have 4 gallons, it equals 16 quarts. 16 quarts equals 64 cups. Make sense? So this is 64 cups. Yeah? Any questions about creating or reading a table? So in total, what this function is telling us is the equivalence for gallons. How many gallons equals the number of cups, right? That's what we're converting between gallons to cups by using quarts in between. So if I told you I have 8 gallons and I want to know how many cups there are, what would you tell me? 128 cups. And why is that?
Because 8 gallons equals 32 quarts, 32 quarts equals 128 gallons.
Perfect. We can read a table with composition. Cool. All right. Nope. All right. This is undoing. So this is undoing the composition. You're asking yourself, what two functions created this? Does that make sense? So there's many answers actually. But you're undoing the composition. So what is your f of x and what is your g of x? So your f of x in this case is your inside. What would be the inside function here?
2x minus 1.
There we go. So f of x equals 2x minus 1.
Oh,
Your g of x is, what is your outside?
X
To the 5th.
Oh, okay.
Y'all are ready to be mad for no reason. Was that terrible? So again, I was looking at the station. Easy killer. She did. I'm not playing with you. All right, again, inside, what is your inside? What is your outside function?
Let's be the test.
Okay, fractions get a little different. What is your inside? 2 minus x. What is the outside then? Oh my gosh, you undid composition. Good job.
Test.
It is possibly on your quiz tomorrow.
Well,
That's crazy.
I'm pretty sure I told you all had a 5.1 quiz when I showed you it on here.
Oh, yeah.
I'm pretty sure I did. When we miss class, we miss knowledge.
Oh.
All right, yes, can we undo?
yeah.
Are we comfortable with undoing? All right, remember you focus on the inside and work your way. Okay, so that concludes 5.1.